start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. No engines, no libraries. This is a complete game code base from start to finish that you can compile by itself, and it's a whole game. It does not even use a graphics card. It actually does all the rendering itself even, which is kind of crazy. But what's not so crazy is our asset loading system. And we've got some work from yesterday that we need to do in order to finish up sort of the basic functionality that we were trying to put into our asset loading system, which was keeping a consistent amount of memory used in the asset system while still allowing the game to run on top of it seamlessly. And so I'd like to jump right into that because we kind of just stopped in the middle of it yesterday. Today is day 159, so if you would like to follow along at home and you pre-ordered the game on handmadehero.org, you will want to unpack day 158 source code, because that is the source code that I am starting with today. So I am going to go ahead and pull that up, and here we go. So I will go ahead and compile this. A little bit slow there. I'm not sure why it's so slow today. Look at how slow that. Look at how long that compile is taking. Guess that was just getting things into the cache. What's going on? Why is that so slow? Do we know why that's so slow? Do we know? Let's take a look. Processes. Doesn't look that unusual. Must have just been a cache thing? I don't know. It's kind of awesome to see how many IO write bytes OBS has done. Anyway, so what we did yesterday is I kind of showed you how to, if we were just going to punt to the operating system and let it manage memory for us, we kind of showed how to do that. But there was a particular thing that I needed to finish up from yesterday that we didn't have time to do on the stream. And that is that even though our system is sort of technically working at this point, there is a critical bug in it that we already kind of planned for and knew would happen. But we don't actually yet really use the things that we did to prevent it from being a problem. And that is when assets are loaded into the system. Obviously, now that we want the asset system to use only a fixed amount, a certain amount of memory, what that means is that assets that are loaded can get unloaded. So when an asset in the asset system gets loaded in and its state gets set to asset loaded, well, at any time, at the end of a frame, right? I shouldn't say it at any time. At the end of any frame, a given asset may get jettisoned in order to make space for future asset loads. So that's not a problem for any of our normal rendering, but for if we have any tasks that are running in the background to do rendering, which we already have in the case of our ground chunks, for example, then what we would like to do is make sure that anything that they are trying to use can't be evicted. Because if it was evicted, then their code would crash because they would be trying to be using an asset that doesn't exist anymore, right? So we need to have some kind of a notion of whether or not the asset itself is actually present. And then we need to know whether it's being used by one of those background tasks. So loaded and locked is what we decided for there. Loaded just means it's there but could be unloaded at some point because no background task is using it. But locked means some background task is using it, and therefore it's not safe to simply assume that you can get rid of it. So what I'd like to do is start by actually working with this locked flag a little bit. And what you can see here is that actually locked, we never really set anything to locked, and that's the problem. So if you look, that never actually occurs. And so at some point, we go in, and you can kind of see where if we were to jettison something, we have places where we actually jettison it, right? We have places where we go ahead and unload stuff in evict asset. So what we need to do now is make sure that anything that could get into evict asset is something that would only be set to asset state loaded, right? And we have an assertion here for it, so we know that this routine will assert if we ever try to unload something that wasn't loaded. But what we need to do now is make it so that we're actually using that locked state so that we never get to that point, right? And we can kind of see where this is happening. So when we do add header to list, for example, anything that calls add asset header to list, like these two guys right here, that should only be happening if the final state that this thing is going to go into is loaded and not locked, right? If it's locked, that's not going to cut it, right? So we need to do a thing here where we're sort of seeing whether or not this asset's going to be locked. And when we do a load bitmap call, that's kind of going to be that's going to be something that we need to start thinking about. So what I'm going to do here is just introduce a thing that's like, if this thing is going to be locked, then we would sort of not do that thing, right? And similarly, I want to change this, so we're going to do like, okay, if this thing is going to be locked, we're going to set it to locked, otherwise we're going to set it to loaded, right? And so I want to do that, and I want to do that in both places, right? I want to do that here as well, so I want to do, if it's locked, we're not going to do it, and let's see here as well, we're going to set it to locked, right? And then what I'm going to do is inside load bitmap, I'm going to introduce the notion of the locking here, right? And just sort of set that up. Now, this isn't the cleanest way to do it. There's some things that I might want to do differently eventually, but we're going to take it one step at a time here. So let's take a look at handmade assets load calls. Here they are in here. I don't really know why those are in here. I guess so that they can be called like this. But we've got a little thing here that's going to do our locked there. And in our prefetch, is prefetch even used? So prefetch is. Prefetch is used for sound, but not bitmap, is basically what happens. So that's fine. So we're going to have those locks in there. And we're going to go ahead and say it. And I guess, to be fair, we really don't even need locked for sounds, because sounds can't really be locked. So it might be the case that actually I just go ahead and say, well, and I could even say that prefetching bitmaps, you can't lock a prefetch either. So we're just talking about bitmap loads. Those are the only things that will ever be lockable, right? Well, I don't know. For completeness. Let's just say for completeness. Okay. So let's go ahead and do that. And I want to take a look at load sound here and just say, you know what, never mind. What I said before was a total lie. Sound, since we never have to lock those can just stay completely unlocked. And off we go. Right? So there we go. And now we've got load bitmap here. Load bitmap is something that gets called in push bitmap. And what I want to do is say that the render group itself knows whether or not assets should be locked, right? And what I want to do is I want to make sure that instead of trusting like the caller to always do the right thing with locking assets, I want to basically introduce a thing where, well, I guess I could do it this way. Just say I want to be able to assert that if you are in a situation where you think you should always be locking the assets, that either, you know, that's not the case, or the asset itself actually is locked, right? So if I get the state of the asset, so let's see, I guess loaded bitmap doesn't have the slot ID, so I could just say this. If I get the state of the asset, then it should be locked. Right? Asset locked. Like so. You know, get bitmap could even do that check as well. Kind of like the idea of that, so maybe I want to do it this way even. I think that's even perhaps a little bit better. So get bitmap. Again, the reason I'm thinking this, I'm trying to design a system here. I'm trying to make it so that it's hard for somebody to do the wrong thing. Because it's easy, it might be easy to accidentally type something wrong in there. So what I'm thinking is that when you start up your render group, right, you just have an asset should be locked setting. And that way, you kind of know that the render group will always do the right thing, and your code can kind of be stupid and just ask for assets, and it doesn't really matter, right? So that's my thinking. So when you do an allocate render group, we'll do a, like, you know, assets should be locked, and then it'll say in here that the asset should be locked, and then everything should be good. So let's take a look at that get bitmap call. I think that's actually in the H file, right? And so what happens here is when we do the get state and we check to make sure that it should be locked, what I want to do there is just say, oh, okay, when you get in here, why don't you also assert on the slot that it either equals asset locked, right? Or the assets don't have to be locked. Must be locked, right? So I want to assert that either it doesn't have to be locked or it actually was locked, one or the other, and off we go, right? So then what we can do is when we fill ground chunk, we can just say that the assets have to be locked, but when we do our game rendering, we can say that the assets don't have to be locked, right? And that way, now we should have a situation where it kind of takes care of itself. So now what we can do is kind of go, all right, let's, yeah, in fact, we're already getting the situation where our asserts are catching stuff. So now we just have to go through and double check that everything that we did is actually reasonable. It looks like, for some reason, this slot here, what does the actual slot say? Let's take a look. So that's state 3, which again would be loaded, right? If you take a look at the asset file, states, oh wait, 0, 1, 2, 3. 3 is locked. Oh, right. That's exactly what the is trying to prevent. It's not loaded, right? It's locked. So somehow somebody got in there who was actually locked, and so we need to figure out how it was possible for somebody to get in that array. So did I mess up? Let's take a look. On load bitmap, let's see. If it's supposed to be locked, it sets it to locked. If it's not locked, it adds it to the list. So how did something get into the list? That doesn't make sense. How did something get into the list that itself was locked? That's kind of weird, don't you think? I'm going to go ahead and say when something, I guess something could transition, I suppose. But I'm going to go ahead and check here and say, okay, we've got the slot index, so I want to assert that when we add something to this list, right, it cannot be set to loaded. There's kind of another weird thing about this, right? We add to the list single-threaded here, right? And that's a little wonky because that means that things are in the list before they've actually been set to loaded. They could be just not loaded yet. And it's almost impossible to conceive of them actually being freed before they were loaded, but we do probably need to make sure that that's not happening, right? Yeah, so that's a little tricky. But if add asset header to list, let's take a look, header to list, like so. This one, that's the problem. Typo there. Okay, so that should be fine. But what I was saying is, like, you know, when we go to evict an asset, right, when we grab that first asset out of this list, we don't actually know that it's been loaded. It might just not be loaded, right? So what we really need to do is we need to iterate over until we are actually able to find one that isn't, right, that is actually loaded, just in case they all are. So what I think we want to do is say, okay, we'll grab the least recently used asset, we'll see if that thing is loaded. If it's not, then we actually need to just go ahead and say, oh, if it's not loaded yet, just abort, and we'll get it next frame after it finishes or whatever. So I'm going to say here, I want to say that make sure that the asset actually is not just the sentinel, and then say the asset should actually also be loaded, right? Like that's kind of just another thing that should happen, right? In fact, what I could do there in evict asset, I feel like since we need the slot here anyway, I feel like this sort of stuff, let me see here, slot gets used here. I feel like we almost want to pass the slot in. So in here, I'd sort of do something like, okay, we've got the slot there, right? So we say, make sure it's not the sentinel. Then we do grab the slot, and we would pass that slot along. And I'd say if get state slot equals asset state loaded, Then we would do the call, right? Else, well, and I could also just do it this way, and then the assert would happen in there. So we'll make sure that it's something above loaded. So that seems a little bit better to me. Let's go ahead and also grab this. See if I got slot index in there. All right. Need the header slot index. So asset. Here we go. So this is really the header. I don't know why we're saying asset here, because it's not really asset. It's actually the header. So there we go. Header. There we go. Okay. Let's see how that goes. So that's very good. That's exactly what we want. You can see all the crazy flashing because I've set that threshold for how much to load to basically be too low to even store the assets for a single frame. So it has to kind of cycle between them. But that's exactly what we kind of want to see, right? So that's all good, right? But let's finish things up here. So we've got one more thing we have to do, which is that right now, I don't know if you remember, but we don't, when we use a bitmap, right? When a bitmap actually gets used, like via get bitmap or get sound, we don't actually move it to the front of the list, but we want to be able to do that, right? Because that's how we check what's the least recently used and most recent reused things. This is just assuming that the list, again, is in that sorted order, and we don't know that it actually is. So what I'm going to do is every time we access the bitmap, I'm just going to move its list element to the front, which, again, is not a particularly good way to do this, but just something that we're going to start with. And like everything, you know, you don't really want to go overboard on making things awesome until you know that the awesomeness just is going to pay off. So if we turn out to do this and it just never ends up being a performance problem, then maybe we don't address it. But there's a lot of probably faster ways we could go about doing things other than by doing a move to front linked list. We could do stuff like having, you know, heaps that get sorted and stuff like this. So, you know, take it with a grain of salt. But point being, in here when we do our get bitmap, what I want to do is I want to do like move header to front, right? Something like this, where every time you use something, we move that something to the front, right? And the problem with this is that, if I remember correctly, our stuff is kind of tortured right now. Like, it's hard to get from slots to headers and that sort of stuff. It's just really kind of tortured. And this is the kind of thing that I don't usually have trouble with when programming, but on stream, it's really hard for me to envision complex data structures while I'm talking. It's like really, really difficult. Whereas normally they're just kind of in my head and happy and it's easy. So things tend to get a little bit tortured, unfortunately, and that's sort of the state that I feel like this is in at the moment, which is to say that, like, we have this asset memory header thing, right? And it's got a way of getting back to the asset slot, right? Because it's got the slot index. But really, it's kind of annoying. But the reason that we wanted to do that is because we didn't want all the slots in the game to have this all the time. We only wanted the stuff that we actually loaded to have that, right? And so you kind of see how that's a little bit of an issue, right? But we can get back to the header. We can get back to the header because we know what its layout actually is. So in theory, right, we can do a move header to front call, and it would actually work. It's just a little ugly. So I'll write it, but it's something worth noting is we can probably simplify this code a little by changing our organization of how things are lined up and thinking about it a little bit more sanely, right? But anyway, what would that look like? That would just look like us sending the assets and probably the slot itself, right? So that it could be determined which one it was here. So we'd call move header to front on the asset and the slot, and move header to front would kind of do this little dance with it, right? And so I'm going to go ahead and predefine that one, right? Internal void move header to front, and that's going to be game assets, and asset slot. Okay. So when we compile, it will not find that, right? And what we want to do here is we want to introduce this function, something that will take an asset slot and move its corresponding header to the front of the list so that it will be like the last thing freed. If you were to then do a free at that time, it would be the very last in the list of things to be freed. So when we do move header to front, what we're looking to do here is we are looking to take the header and do sort of a remap of it, right? So we're looking to do a asset memory header. So we're looking to take that. Somehow we get to that from the slot, right? We're looking to take the asset memory header, and we're going to take it out of the location that it was in, right? So we're going to do something like we did before, where we remap it. So we say its previous points to its next, and its next, the previous, the thing that is after this link, its previous should point to our previous, right? The thing before us. And the thing that was before us, its next pointer should point to the thing that was after us, right? So it's like we never existed, right? And then what we want to do is we want to reinsert ourselves. We want to reinsert ourselves in a very specific location, which is immediately after the sentinel, right? So we want to go ahead and take the loaded asset sentinel and say that that's our previous, right? And our next is going to be that same loaded asset sentinel, whatever was previously the first thing in the list, right? And then we're just going to link them up again like we were doing before, right? So now our previous next points to us, and our next previous points to us as well, right? And that would be all we really need to do. So the actual insertion and removal code is pretty straightforward. We've already done it once, and we could coalesce this code, in fact, with the other code if we wanted to, because it's basically the same. But the problem here is that we don't know how to get the header, right, from the slot. That's actually fairly tricky, and if you see the way that that actually worked before, you can kind of see that it did this sort of nonsense, right? And so in order to, kind of make that, happen, and you know what? Now that I look at it too, you could almost envision just kind of doing this directly, right? Where we kind of just call add asset header to list, because it always does add it in exactly the same way. So we could just call this, right? We could just call add asset header to list, like so, and it would just be a question of how do we get the header. So move header to front would just be this call, right? So we could do that if we wanted to. Something like this. Inline void link asset header like this, or put asset header, insert asset header at front, and it would literally just be this code, so that we don't have to know the slot index, right? And so, yeah, insert asset header at front, assets, memory, size, like so. So we could do that, right? We could do it that way, and I guess we just pass the header, actually. We wouldn't need to pass anything else. And so the question, again, is just how do we get that, that header, right? So now we just do insert asset header at front. There's the header, right? And ooh, I deleted a little more than I should have there because I wanted that removal. But remove asset header from list already exists as well, right? So I can just call that, and there we go. So again, I think that's all pretty easy. Like I said, that way we don't have to duplicate that code at all. It's all just kind of nice and sane. The problem is, and I can inline these so that the 0 setting will get optimized out. Not that we care, but it would. So the only problem here is just figuring out move header to front is just figuring out where that header comes from. Now we know that we can always do it this way, right? We know that will always work. but we don't actually have this information at the moment. And so in order to get that information, right, since we stored it at the end, we would have to sort of do the same thing that we did before. So like when we call load bitmap or whatever, right, when we do the thing that says get size of asset or whatever, right, we would have to do that thing here where we say, oh, okay, you know, how big is this thing, whatever it is, and which type is it, right, which we could also get. So as we could get type, right, get asset type, or is it just get type? So we can get the type, and we could find out what the, let's see what get size asset. What does it do with the slot index? So it just uses that to get the asset handle out, right? So really get size of asset probably wants to be looking at an actual asset, right? So that way you don't need to know the slot index. You could just have the asset. Of course, in this case, we don't have the actual asset, do we? So I guess that doesn't necessarily help us. Never mind. I was going to say we could be a little clever there. So yeah, let's go ahead and compile that. So in this case, we don't actually know, in order to get the size of the asset, we need to know what the slot index actually is. So, oh well, still need to know that. It's okay, we have it. Everywhere who calls move header to front, we do have the asset slot index, right? So that's all good. Oops. Actually put it in. So that's not a problem. But again, it's just sloppy, right? It's like I was saying, I think it's just architected a little wrong in terms of the way the data storage is not laid out in the way that would be easy to do this. So it kind of warrants some attention in a second. But again, I just want to kind of finish what we're doing here. So get bitmap function does not take 3 arguments. That is because I erroneously introduced slot index into it for no apparent reason. Don't know why I did that. It's just dumb. And then this is actually id.value. It's been a long day. It has been a long day. All right, so really I think insert header at front takes game assets as well. I think we are down to just the fact that we need to know the memory, right? And in order to know the memory, we have that information, but again, it's just kind of janky, right? Because if you take a look at how that memory is being retrieved, or where I guess I should say where it's being saved. In the case of a bitmap, we have it here, right? So we kind of have like a thing where we're like, okay, we've got memory, and we have to do a thing where we say like, okay, which type of slot is this, right? It's let's see here. It's a bitmap or it's a sound. And in those cases, we have to like go do the super nasty thing where we're like, okay, fine, give me the bitmap memory in this case, give me the sound memory right in this case. And that's just samples. So that's everything, as terrifying as that is. But I probably made a little mistakes in there, and then that is the kind of difficult part. Wait, what? How is header null? That's kind of strange. What just happened there? Get bitmap. Oh, although one thing that I should think of too is that move header to front also only counts for loaded bitmaps because other ones aren't actually in there, if that makes sense. But I don't really know why that should still have given you a valid header. Okay, it does. So that's all fine. That's all fine. Yeah, so in move editor to front, I also want to do a get state on the slot, and I want to make sure that when I do a get state on the slot, that's going to be loaded, right? Or rather just not locked, because locked things aren't in there. Right? Again, yeah, I feel like it's probably just going to be time to clean up this code. It's just really too messy at this point. Because if you look at, there's another kind of nasty thing in there, which is that when things get inserted in, originally we don't know, like locked is really a flag. It's not a state, right? Locked should just be, it shouldn't be asset state locked. Because we need to know whether that's the slot is locked or not determines whether or not it has a header. It doesn't matter whether it's been loaded yet or not. If it's locked, it doesn't go in there, right? And so that part is kind of also troubling me. So I feel like this also is like asset state loaded is just plain, unloaded, queued, and loaded are separate things. And then there's, an asset state locked, which is like a separate thing. Maybe we'll change the name of it just so we can tell, and it's some flag that everything can have on it. That's way more sane. And that would be like, is locked or something like that. And so that way we just always use that, and we'd always have a thing that was like, is locked on an asset slot. And that would actually just return whatever the state of that asset slot was, ANDed with the lock flag. And the reason that I want that is, again, because it's just things can have 3 different states, essentially assets can, and the asset is a locked asset or not, regardless of which state it's in. It's not like assets only get locked once they're loaded. They're kind of just locked, period. So it's locked even when it's queued, right? It's still that property, this cannot be unloaded, is kind of just something that's just true, right, about the thing. And so what I kind of want to do is just say that that's just a formal thing, and like, forget it. It's like it is or it isn't locked always, and it doesn't have anything to do with whether the thing was loaded or not or anything else, right? So that seems like a better idea to me. So I'm going to go ahead in here and say that what's supposed to happen is like, okay, if I'm going to get a bitmap, right, and it must be locked, then what I want to do is I want to say, let's see here. When we get the state, we look to see whether it's loaded or not. If it must be locked, I want to say like is locked, right? So that's good. And these guys don't care about locking. In here, yeah, so in here, what we have is, as soon as you actually try to load a bitmap, what you want to do at that very moment is immediately set its state to locked, right? So it's always going to be loaded, it's always going to be a bitmap, and then possibly you will OR in also that lock flag, right? But before you do anything else, you will also set the state of this thing to be locked, right? So you will simply say, yeah, whatever this asset slot state is, it's locked now. Because anyone wants to lock it, it becomes locked, right? So that's all fine. And so when we do our move header to front, we want to only do that for assets that aren't locked. And that seems a little saner to me, if that makes sense. So let's take a look here, step in here, and we look at the slot. We can see that this is a locked one, so since it's a locked one, it will not actually do its thing. Let's see here. Okay. So let's keep going. We now have a get state equals asset loaded thing. What I really want is to assert also that it's not locked, right? I want to make sure we never do stuff that's locked everywhere. So all of this code, I think we're now mostly at the point where it's good, but we still have some things like, I feel like we're at the point where it's like, you know, sort of cobbled together working, but it's not good, I guess is what I should say. It's not like what I would like the code to be doing. But it's almost there. So we just need a little bit of cleanup, and then it would be in a reasonable state. And then from there, I think what I really would like to do is just kind of go through and refine the way the sort of slot asset thing is working to get it into a place where we don't have to constantly bounce around so much, and maybe we can just do something like a little bit handier there, right? A little bit nicer. Okay, so let's see. What I don't know at this point is really like... So I guess what I don't really know how I can test this reasonably, because we, you know, until we get some debug visualization in there, it's hard for me to tell whether or not this is actually working reasonably, right? Because if I set it low enough, right, if I set the actual asset stuff low enough, then it will get into a situation where it can't really function, and it'll have to page out things that it actually needed. But if I set it too high, then I won't know that it's actually getting hit, right? And so it's a little janky that way. So let's say I said 4 megabytes was how much it had to work with, right? And that's clearly still paging stuff out. And I know because the hero blinks when he turns, right? And so it is actually keeping things paged in and out, right? Which is kind of interesting. So let me take a little look here at what's going on of Handmade Hero. We could also reduce the memory footprint quite a bit of the whole app and see like what this actually looked like. But I'm just kind of going to play with it here. So you can kind of see it working okay. You can see this commit size number, like hovering where it should hover, right? It's like going up a little bit and then it goes down, right? As it sort of pages in and out and tries to keep itself at the appropriate memory limit, right? We really need to just load a bunch more assets, and that's probably something we can look at doing a little bit later, but that's looking okay. Okay, so I'm going to call that working for now. Again, until we have some more debug code, which is kind of the next thing on our list, actually, which is kind of nice, I believe. If we take a look up here at our to-do list, right? We've got debug. Well, I guess it's not necessarily next on the list, but we could say that is going to be up there pretty high. Particle systems, hilariously enough, we've already done. But yeah. Anyway, if I take a look at this and I said maybe this is the thing that we do, we'd fix the audio clicking because, well, actually, you know what? We'll do the debug code and we'll use that to fix the clicking. So making debug code next on this might be good too, because that would allow us to actually start taking a look at some of these things and see how well they're working, which is something that we can't really do at the moment. We just kind of have to go, well, it kind of looks like it works, which doesn't really help us. So what I'd like to do now is take a look at what we have and try to simplify. There's just too much fussing, in my opinion, between like the asset slots, the asset, and the memory header, right? It's an issue. And I don't love it, right? So I kind of feel like we need to start condensing these things in some more intelligent way, right? And that seems to me like what we should really be doing. So I'm going to take a look here at what we actually have to marshal and see what I can do if I don't melt first. It's pretty hot in Seattle again. It's very hot here. So we have the data offset. which is where in the file we get stuff. We have the first tag index and one past last seconds, which tells us our tag range. And then we have the bitmap and sound info, right? So that's the data that we're actually keeping for each one of these that we got out of the file, and that tells us how to use the thing, right? So that's all good. We then have a file index. And the file index is really just an index into the file set. So what we could do without really adding any additional memory to this if we wanted to, right, is we could just say that we have the slot state and the file index. Like it really wouldn't be too much of a stretch to just kind of merge these two things together. Like keeping the asset slots separate wouldn't really be a huge deal. I mean merging them together. Because I kind of said like, oh, we could keep it separate, but we don't really know that we need to separate them. And we could save that for later if we decided we need to separate them for some kind of reason. And so cleaning things up to make it so there's just an asset and not an asset slot might actually make it so that there's just one less thing to worry about. And that'd be a pretty easy change to make, right? So for example, a transformation of this code I could make that would be really straightforward is just to do that, right? Or something like this, and say, okay, the asset slot and the asset are now just one thing. Okay? And so if I did that, let's just see what that would do. Right? So now we don't have asset slot anymore, we just have assets. And so everywhere that was looking at one of these things is now just only has to look at one of them. Right? So that's all good. And we could sort of just say that slot becomes asset now. Right? And these are all just asset things. So asset slot becomes asset, like so. And slot becomes asset. So asset index, assets, asset, 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 asset. Right? So let's see how this goes. Again, now we just have asset. We don't have to deal with slots, just assets. And so work asset state equals the final state. We've got an asset slot. This becomes an asset. Assets. Again, I guess asset slot becomes asset. Asset, asset, asset. And so on. Let's go ahead and take a look here. Slot becomes asset. Slot, slot, slots, slot, slot. I think basically just everywhere we were using slot is just now an asset. Right? Okay. So asset index is not a member of the header. That is true, because it's still called slot index in here. So here we'll just call it asset index, and off we go. Right? So that's all good. Asset index, asset index, asset index. Okay. So that's all good. Nothing strange going on there. So now let's see what we could do. What could we do to simplify things further, right? What can I do here? So another big problem we have is we've got this asset memory header, right? And the asset memory header is stored in whichever one of these things actually gets loaded here, right? So how do I want to deal with that? Like, what do I actually want to have happen there? I think what I want to have happen there, I'm just going to throw this out there. Stop me if I'm going crazy. You know, stop me if I'm just going banana cakes on you. What if we were to do the very simple potential transformation of saying, all right, we've got the state, and then we've just got a pointer to the asset memory header, right? So we've got the asset, we've got a pointer to the asset memory header, and the asset memory header is the thing that actually has this in it, right? And in here, we've got a thing that's like the type of the asset, And so then we have a thing that's like asset type, right? It's got sound or bitmap in it, like so. Something like this, you know? In fact, we could actually make that just be that. Something like this. Tell me how you're feeling about this. Are you feeling this? I don't know if you're feeling it or not. I'll be honest with you, I just really have no idea at this point. But, you know, only you know how you feel about it. So I do something like that, right? And now we're starting to get somewhere. Because now it's very clean. You just say, okay, there's an asset. It's got an asset memory header. And that asset memory header tells you whether this thing actually is sort of in the queue. In fact, it's almost as if we might not even really need this anymore all that much. But yeah, I don't know. So the lock would really be the thing. I think maybe that should be down in here, whether this thing is locked or not. So we just have unloaded, queued, or loaded. So I'm not sure about where the lock goes yet. So we're just going to play with this first. I'm going to see what happens if I just do this one transformation and start to clean up the problems with it, right? Okay. Oops. So this is like, this can't really be asset type here. So I don't know what we'd call this. Asset memory type, something like that. I don't know. Not a good name, but what are you going to do? So in here we have asset type mask. We don't need that anymore because really if you want to get the type of an asset, you need to be talking about that asset headers type thing. I'm going to remove this temporarily and see who calls it and actually handle it at the call site, I think. Because I want to see what they're doing. All right, so yes, that's true. Asset is not a member of bitmap. So what we can do here is say, okay, it's just the header, right? And we can assert that the asset header, well, we don't even need to. It'll immediately fault if that's not the case. So when you grab the bitmap, we just get it that way. We grab the sound, we get it out of the header like so, right? And then in here, we would need to do the same exact thing, right? So we get that out of the header. Now the key thing though is that header doesn't exist yet, right? So what we would need to do there is we would need to allocate the memory first. So we would do the asset memory size situation. We would then sort of get the memory out. So we'd say the asset, right, header equals acquire asset memory, like so. I'm liking where this is going, people. Are you feeling this? I feel like you should be feeling this at this point. I don't know if you are or not. But you know, I might suggest at this point that if you're not feeling it, maybe that's you and not me. Okay? Like I don't want to criticize you, right? You know, you have the right to your own opinion. I'm just trying to say maybe that opinion's wrong, right? I'll put it out there, you know. I mean, you got to call a spade at some point, right? And you know, you don't get an E for effort in this class, okay? You got to keep up. All right, so in this case, when we do the asset memory stuff, you can kind of see what I'm doing. I'm saying, okay, the header is now primal. So when we allocate the memory, the header is the memory. And this is kind of starting to unwind that sort of nasty, where is the header versus the bitmap sound, whatever. It's like that stuff is kind of condensing now into it's just a little, all of the stuff that was necessary for when the asset is loaded is now all in this header, and it all kind of is nice and clean and we know where it is, right? So it's just, I'm just untangling that mess, right? So that it's not a mess anymore, at least to the extent that we can make that happen, right? So that's all good. And let's keep going here. So here's our sound. We actually don't want the, where am I doing the bitmap header? Bitmap, yeah, that's what we want. So in here, we're going to do the exact same thing. I'm going to come up here. And I'm going to say that the asset header is going to be that asset memory header. I'm going to get that from this guy, right? And that's all good. Everyone loves that. And then I can do asset header sound after we get the memory, right? And then when we do the loading here, where we do the destination memory thing, that's again just going to be header plus 1. So exactly the same, asset header plus 1. The extra memory that we allocated as part of that allocation is what goes in there. So let's keep going here. Size, dot total. I need to move that guy up here like that. And that's fine. And there we go. Let's see. And so sound at, yeah, is just going to kind of be, is going to be this again. So I guess I do maybe want void star memory to still be defined here because it has to happen with this dude, like so, right? All right. So now when we do move header to front, all of this stuff gets way cleaner, I think. That's my guess anyway. So basically, we get this thing. Now you don't need to pass the slot index because you've already got the asset, right? So now you say, okay, I don't care what size the asset is, doesn't matter, right? I'm going to ignore what type it is even because I already have the header, right? To get the header, it's just asset header. That's it, right? Bam. Done. And off you go, right? Way, 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 way nicer than it was before. Move header to front. No longer needs that asset index, right? So that's gone. Goodbye. That is also gone. Goodbye. Okay. In here, exactly. Okay, so this is just great, right? All this garbage goes away. Totally not necessary anymore. Totally not necessary anymore because no matter what the type is, we already know how to release it. Although I guess we don't know the size though. We could keep the size in there now because again, now everything's shoved out into the header. It's only there when we actually allocate. So we don't have to worry about it kind of multiplying itself out. So that's another thing we could fix. But I'll leave this for now, just for now. And we don't have to do the memory thing. So we can just do that, right? We can just do that. And then come in here and say, okay, release asset memory. It's going to be the header, so asset header. And then that becomes 0, right? Okay. And so now in here, if we want to know the type of this guy, we would just look at the headers type, field, and then we need to set that at some point. We would need to. Is that the only place now that the person needs to get? That's like the only place, right? I mean, that's it. So I would say just the heck with it, right? Don't even store the type then at that point. If we no longer care, right, we just store the size, right? I mean, total size, right? Does that make sense? Because now if we just store the total size, then we don't need to do this anymore either. We just say, oh, okay, it's the asset, header, total size, right? That's all we needed to know. And that's way better. So then when we do the header stuff here, I feel like that's pretty much all we need to do. We just need to actually save that information. So at the place where it does its asset index nonsense here, right, and add asset header to list, it just needs to do header total size equals size total, right? It just needs to, oops, that's not good. Just needs to save that off. All right. So not quite there yet. All right. So let's see here. How are we getting an asset header of null there? Get sound. Everybody should have their header if they're actually valid, right? If they're actually loaded, everyone should have had their header set. Asset header equals acquire memory, load sound, asset header equals acquire asset memory, like so. Asset header equals, when we release asset memory here, and we set their state equal to unloaded, that should be fine. All right, but we're still a little janky, unfortunately. All right, so what happened there exactly? Show me what happened, Mr. Code. Show me on the code where it nulled you. So load bitmap, we are inside the get bitmap call. We wanted to call move header to front. The asset file, the asset itself that we're talking about here, is not actually in the list. Is not actually in the list. So is this guy, remove asset header from list? Let me see. But that's okay. Remove asset header from list. Remove asset header from list. I say. Oh man! I left this in there. Look at that. What is that doing there? That's just nonsense. That's total nonsense. That's just, right? That's just lame. That's no good at all. And so, yeah. That's our problem. So we just need to go ahead and get out the actual header, and then we'll be fine. So now we're in better shape. Now we are in better shape. And this should not take the memory, because that memory is now totally not relevant. All right. All right, so now we're back to good, barring a little bit problem there. So that's all fine. But looks like we don't quite have our loaded, locked sort of situation quite correct. Although get state asset, what is our asset state? State is 3. Where's that at? Oh, and we have to do the asset memory type thing too, right? That's got to go away. So this stuff, right? Get size of asset. This all gets unwound as well. Man, this just goes, we're just going nuts here. Right? Because we were still ORing in this nonsense, which we don't want at all. So yeah, this is just all going to kind of unwind very nicely. So we want to get rid of that and get rid of that, right? And so what we want to do here is say that this get size of asset thing, you know, this is just for now. I could even just do is sound, something like this, right? And do, you know, okay, if it is a sound, then do this, otherwise do this, and off you go, right? But that's not, I can unwind it further and kind of go back to the original way we had things in a second here, right? So hold on 1 second while I do that. And now, we should be 1 step closer, in theory, right? And so there's one other thing that it would be nice to be just to unwind that get size thing, right? So let's unwind that get size thing as well. What we would like to do here is instead of get size of asset having to actually be sort of this separate thing, we just say, okay, well, if it is a sound, which it is, like in this case, right, then we're going to compute this stuff. So we're basically just undoing the code change that we did before. We're just saying, okay, you know, get rid of this, and the size of the thing, the asset memory size of the thing, can be computed in a different way here. So it would just be saying, I could even keep sort of this notion around where I just do something like size, like so. I say the section size is this, the data size is this, and the total size is this, right? So we could still kind of just cut and paste the code exactly as it is in place. And then I do the same thing for the bitmaps, right? So the bitmap would look like this, like so. Drop that into the bitmap code up here. And that would just be, again, size, size, size. Like so. Okay. Let's go ahead and compile that, fix any problems that we've got there. Don't need that duplicate. And results.section. So that's size.section. Okay, cleaner still. Less code is better code. Pretty much always. And so now we're back to pretty good. We're now, we've added that stuff and we're only 500 lines, which is better. We kind of things were getting kind of multiplied out there a little bit too much. But that's pretty good. And now we could sort of get rid of asset memory size and return this code kind of a little bit back to its further state. But I think that's good for today. We're at an hour. So I'm going to go ahead and go to the Q&A. For those of you who have questions, now would be a good time to ask them. Please prefix your questions with Q colons so I can see them. Because if I can't see them, I can't answer them. Your head was over the window when you were looking at the commit size. I highly doubt that, because I have I don't think that's true. Maybe that was true. Oh man, no, you're right. That could be true, because this is an on-top window. There we go. That's a little bit better. I should probably leave it that way on stream, because that way it goes behind this so I can see what you can't see. Where is Handmade? There we go. Although for some reason it's back to always on top. I don't know. I guess there's not much I can do about that other than just to be sort of semi-vigilant about it. Constantinople. The linked list way of computing least used assets seems like a simple and neat trick. What are its drawbacks? Really, the primary drawback of it is it's just too much work, right? Because if you think about it, right, what's the minimal amount of information that's necessary to know whether this asset was used on a frame? Like, we just need like one integer or something, right, that says it was used on this frame or something like that, right? And so if you think about the cost to update one integer, right, versus the cost to do the move to front thing. The move to front thing, it writes the next pointer and the previous pointer, right? And those are, so this is 4 bytes, right? It writes all of these 8-byte values, the next and the previous pointers of the links on either side of it to remove it, right? So removal has to rewrite those two. And then it has to rewrite its own next and previous, right? So own. This is like our before. And this is our after. And then we have to insert it. We have to tell the people who we're inserting near what to do, and that's the same thing, right? So we have removal and addition. So we're talking about writing 6 by 8, best case, 6 by 8 bytes every time we touch the resource, rather than maybe something more like 4 bytes or 8 bytes, right? And these are scattered around memory, so each one of those is going to make a new cache line hot. And so it's just a lot of extra work. And so you'd rather kind of be somewhere more like this if you cared. Now, again, we may not care. We may leave that in there till the game ships and it's just fine and it does not matter. And the important part of the algorithm is just that we know that what was recently used, because we just don't hit bitmaps that often compared to the rest of the work we have to do to make it matter, right? And so that may be true. But if you're just kind of thinking about what the drawbacks are, well, there's some pretty obvious ones, and it's just that it's a lot of work compared to other things that we might be able to do. You never know. So I'm not gonna say it's bad. Every algorithm has its usage. It might be fine for us, but there might be reasons why it's not okay. Garlando Bloom may be too drunk today. Okay. Well, it's 3 hours later where he is, and the kind of time when people might be drunk. Can you explain the code in which you change the asset loading so that it stops blinking the bitmaps and sounds? Sure. So let's do a simple experiment. What could we do to bring the blinking back, right? Well, what I'm going to do is I'm going to go ahead and say, instead of evicting the assets that were least recently used, I'm going to remove the ones that were most recently used, right? And I'll explain this in a second. I just want to show you. Right? Or not. There we go. Like we have to actually just get to a point where we hit the mem barrier, right? And so you can see how all this stuff is disappearing, right? But in theory, if I go ahead and change that back to the other way it was, right? Now everything's fine. So what's happening here? What's going on? And you can still see that assets are being evicted because new assets sometimes take a frame to page in. I don't know if you can see the little guy blink. But so we still are very asset constrained, and it's having to free all these assets because we made it super memory constrained. It's only using I don't know how much, 4 megabytes for assets, 3 megabytes for assets right now, which is a joke, compared to how big it will be when we actually allow it to use most of the memory in the game for assets, which is what we will do. But let's talk about what happened there. So this is the piece of code. And what's supposed to be happening here, right, is we have a recency list, basically. And what the recency list is it's a sentinel, right, that we keep, which is basically a dummy link in our linked list. And what it is it's the link that's sort of the head and tail of the linked list. It has a previous pointer, and it has a next pointer. All good. All right. So the previous pointer is pointing to the tail of the list. The next pointer is pointing to the head of the list, right? And the list kind of goes on like this. Right? It's a big circular list. In fact, maybe I should draw it a little bit slightly differently just to make it clearer, right? So let's say this is the list, right? So there's the next pointer, next pointer, next pointer. And this next pointer comes all the way back around. Meanwhile, the previous pointers are like previous, 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 but this previous pointer goes all the way over here. So it's a circular list, right? I wonder if we could even do it like this. Okay. Next pointer, previous pointer, this is the sentinel, right? So we got something that's like, next, previous, next, previous, next, right? Previous, next, previous, next, previous, next, previous, right? So you can kind of see the previous just kind of wind through the thing this way, and the next wind through it this way. So we just have like counterclockwise and clockwise, right? It's kind of like me exploring ways to draw a doubly linked list. Here's another one that I was just thinking of as well, right? You could imagine it being like this, I guess. Let's see if we can do this. All right. So you can imagine it being like something like this, where you have like previous next, right? Previous next. Not sure if this is making it worse. Previous next, previous next, previous next, right? The nexts all go like this in a ring. And the previous all go the opposite direction. Right? So it's like a little two wheels. One goes counterclockwise, one goes clockwise, right? And these are our links, and here's our sentinel. Sentinel is always there. It's a dummy. It doesn't have any data associated with it, right? But then these guys are actual assets. So this is an asset. This is an asset, whatever. Right? So what happens here is whenever an asset is loaded, it gets inserted in between the sentinel and whatever asset is currently at the head. So it comes in right here, right? So the next pointer of the sentinel will point to it, and the previous pointer of whatever asset was previously at the head will point back to it. So it'll come in right here, okay? Now, every time we use an asset, we also move it to the front as if it was just used, as if it was just added. So if this guy is actually about to be used, we first cut him out of the list, and we jump it so that this guy points over him and this guy points to here, and then we reinsert him up here, right? So what's happening is the circle is constantly being cycled so that the order in which you occur around the circle is the order in which you were most recently used. So this is the guy who was most recently used, right? And we go down less recently used, 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 all the way to the person who was added last, basically, who's the least recently used. Okay? So what we wanted to do to minimize the flicker was to make sure that we never evicted an asset that was very recently used. And so what we did is we said, okay, just take whatever the previous pointer is of the sentinel. That's the person who was touched the longest ago, and he will get evicted, right? And we just keep evicting, we keep pulling people out, get rid of him, this guy would be next, get rid of him, get rid of him. We keep pulling people out until we see that our memory footprint has gone below the target. Will there be a concern of cache misses while manipulating the doubly linked lists every frame? So there is, the concern is theoretically there. In reality, will it probably be a problem? I actually doubt it. But you saw when I was sort of pointing out those, how there's those 6 writes instead of 1 write. You know, it's 6 times worse, you might say. Although the cache, because the next and previous pointers are next to each other, it's really just 3 cache things probably, but it's 3 versus 1, and that's, you know, a thing. But since the next and previous pointers are kind of near to, it's, again, really the answer is you shouldn't be thinking about that right now, right? Because you have absolutely no idea what your cache usage even is in any of the code at this point. So worrying about that is not really very useful. You need to get to the point where you're actually looking at your performance holistically and go, oh, I have too many cache misses here. Why? Because of this linked list, right? And that's really the time that you would think about it. You've got a to-do about the size of the audio asset struct. How important do you think it is to keep structs compact? So at this point, I actually kind of changed my mind about that. And the reason is because, so I fixed that today, basically. This stuff now no longer has to be the case because loaded sound is not in the slot anymore. It's off in the memory header, right? So we totally fixed this. Because the reason I was worried about those things before was because asset slots were proliferating. Like, there's going to be as many asset slots as there are assets. And so that's a big concern. Asset memory header, we don't care at all because the asset memory header only exists for assets that are actually loaded. And what we know is that the asset size itself of the data is going to dwarf whatever else is in there. So now we actually don't have to care about that at all, right? And I can go undo, in fact, that change that we did before, where we were like, oh man, loaded bitmap, we got to make these things, right? It's like, nah, forget it, doesn't matter, right? So we don't need, like, none of that stuff matters at all. Loaded bitmap can be as long as it wants to be. We can get rid of the safe truncates. So all that stuff can just be, you know, whatever. It's totally does not matter, right? So that was actually a really good aspect of today's change, was that we moved something, and I can try to explain that on the whiteboard a little more as well, if that makes sense. But basically, what's going on? Also, there was another one too, right in here. I'm just going to go ahead and get rid of those temporarily and see where they actually were. Right? Okay. So the reason I was concerned is, right, we have an asset slot table, right? So we have an asset table. And the number of assets in here is the total number of assets in the game, right? So this n is large, okay? If we have 100,000 assets in the game, poor Yankshin, if we have 100,000 assets in the game or something, right, then we pay, however big the asset struct size is, we pay 100,000 times that, right? So if the asset struct size is 128 bytes, right, then it was 12 megs, right, for the asset thing. So I didn't want those to, like, proliferate. And so the way that we had it before was that all of the data was in that asset slot, right? The loaded bitmap and the loaded sound and stuff. So I had to worry about how big these were getting. I was actually starting to think about that, right? But as it is, now we've put it so that the only things that are in there are the state and the pointer to the header and the stuff that we actually need to load out of the file again. And we could actually do some stuff to even reduce that further. In fact, I'll put a to-do there, which is to-do should the tag info, oh wait, no, it can't be, never mind. We can't reduce that further, I take it back. So this is like not the minimal amount that we need, but it's getting closer, right? Because what we did is we moved all of that stuff out of the asset and into the asset memory header, and the asset memory header is actually a very small number. This is proportional to the loaded asset count, right? So we might only have like 1,000 assets loaded at a time, right? And we can control that number very easily. This number we can't control. It is however many there are in the game total. But this number we can just dial. because it's just we've written a paging system. We can make this whatever we want. So I no longer have to worry really how big the headers are. And plus, the header is only there if the rest of the data was loaded, and the rest of the data is huge. It's like 256K or something. So hey, at that point, am I going to worry about 16 extra bytes or something? No. And so moving stuff out of here and into here is a big deal because it lets us not care about how big it is. Do you have a hard drive to check this system on it? This is a hard drive. I'm not sure. Are you trying to say versus an SSD drive? This system is a hard drive. It's an old school, spins on a platter hard drive. Is there a problem setting the asset header to null after unlocking it? I thought there was some background loading of some stuff. Well, let's take a look at where you're talking about. Are you talking about here? Right here? Because in that case, when we evict an asset, we know that the loading is not in progress because the loaded is set to true. So when an asset is loaded, there's no more background tasks operating on it, right? And it better be okay to set the header to 0 because we just released the memory that the header's in. Is the heap and the stack just different sections of RAM managed by the OS? Also, if so, do different programs ever share stack space? Would you please shed some light on this or point me to some video of yours that I missed? Yeah, I mean, that's covered in the early Handmade Hero videos. We definitely talked about that. Basically, the heap is not really a thing. The heap is like utility code that runs on top of the system's actual memory manager, which is like the page table, which is like virtual alloc, right? So like a heap is basically a utility allocator that sits on top of your operating system's page table. The stack is basically a reserved memory space that is contiguous and which gets added to as your program calls into functions and returns from functions, it pops it off. And we have talked about those on Handmade Hero before. I'm confused as to what the memory layout will be after using the doubly linked list for a while. The memory will fragment eventually as of now, no. As of now, comma, no. Well, so to be honest with you, the answer is a bit scary, which is I don't know. And the reason that I don't know is because right now we are asking virtual alloc to get us our memory, right? So what we're actually doing right now, remember when we started this, I said let's do it first where we ask the OS for memory and release the OS memory, which will be probably fine on 64-bit systems. I don't know if you get fragmentation of the page table. I honestly just don't know. I don't know very much about NT's page table algorithm. I don't really know. And so that's why I was saying before that I don't think we probably want to leave it this way. Because obviously the next step for our asset system is for us to replace the call to the operating system with our own memory thing, at which point we'll be in a better position to deal with fragmentation. Could we just use an islocked bool inside asset header? Yes, we could. Won't this method of swapping the assets cause memory fragmentation? Again, I really just don't know. I can explain to you why it's a little confusing to know. So normally, right, when you're doing allocation in memory space, right, in virtual memory space. So if you have 2 gigabytes of memory, right, and you allocate something here, and then you allocate something here, and you allocate something here, and then this goes away. Now you have a potential fragment because if you have something big, you can't fit it in there, and you can't fit it in here. But if you had moved this over, back, you could have fit it down here or something, right? So that happens. But the operating system, cheats, right? One of the travesties of modern operating system design is that this stuff isn't exposed to the user space, but the operating system doesn't live in virtual memory space. The operating system lives in physical memory space, right? And so what happens with physical memory space is there's just a bunch of 4K pages. Well, or whatever the page size is, but like, okay, 4K, 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 okay? And what the operating system does is the operating system has a page table that just says, all right, bro says he wants some memory, so I made him some memory. He said he wanted 16K, so I gave him 4 pages starting at page 2, right? So it was like here, 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 and here, right? Make sense? And then later, bro said he wanted he wanted 8K, so I gave that to him starting, right here, right? So this is 2, 3, 4, 5, 6, 7, right? So 6 and 2, right? So here's the count of pages and the index, right? And because the operating system has the luxury of remapping these things, later on, when it frees this, it could use those 4K pages arbitrarily. They don't have to be contiguous, right? Later on, it could say, oh, he freed these 4, and these pages are still used. So these guys are used, but these guys get free, and someone needs 6 pages. Someone needs 12K. Well, it doesn't really matter, because then what it does is it says, 6 pages would not be 12K. 6 pages would be 24K. What it does is goes, okay, I'll just give him these 3, and then I'll give him the other 3 down here. And it can just go ahead and do that because it can say in its page table that these guys and these guys map to a continuous region in the app's virtual memory space. So even though this is 3 pages and then 3 pages that are separate, to the app, it looks like 6 continuous pages of memory. That's the magic of virtual memory mapping. The processor does the translation of the addresses, right? And so I don't know if there's a risk of fragmenting the page table. Because you can imagine there is a thing here that it has to do where it's like, oh, okay, I can't just store a count anymore if I'm doing this thing here. So I don't know. I don't know. Fragmentation is a lot easier to deal with when you have virtual memory mapping. So it may be that the operating system just would never have a fragmentation problem. Captain Duh. So something like this can't happen. Asset evict function is called, release happens, unlock happens, thread context switches to loader, something gets loaded into that slot with some header, thread context switches back, header, oh, no, nothing like that can ever happen. So you're thinking about this a little bit wrong. Let me just clarify that to make it very clear. So when you're doing multi-threaded coding, you have to remember what is and is not multi-threaded, because otherwise you go nuts, right? In our code, we are not multi-thread happy. The only multi-threading code is load asset work, right? This is the only thing that is multi-threaded right now in our asset system. What that means is that the only thing we have to worry about is whether or not something load asset work is going to touch data-wise could be problematic. And what we know is that platform read data from file, well, that's just going to read data into the asset block. So that's pretty much never a problem, right? The only thing we have to make sure that we do is that we don't declare that the asset is ready before that read is finished. That's about it, right? Or we might get some garbage on the screen when it tries to use those bitmap bips, right? So really, once we set the final state thing here, right? Once we set final state, the only thing we have to worry about for the most part is that whatever this guy is doing, it's not going to possibly write to something that the other code was trying to write to as well. And what we know is that when you kick off a load asset work, right? When we kick off a load asset work, the only state that we do that in is when we've done an atomic compare exchange to set an asset into a queued state. And once an asset is in a queued state, no one can ever kick off a background task on it again. And more importantly, no one can use it either because it's queued. So until this actually finishes and marks it as loaded, no one else will ever touch it, right? Make sense? So everything else is single-threaded. There's no way you could be calling this code to kick off an asset read at the same time as you're calling this code to evict an asset because they're in the same thread, right? So they can never conflict with each other. Does that make sense? Is it possible that due to the kernel caching disk accesses, we're paying more than once for each asset? Like after we evict an asset, is another copy of it likely to be cached in physical memory because of the OS's caching of the pack file? The answer is yes. And the reason, though, that that's not particularly troublesome is because presumably before we get to the end of this project, we will be compressing the asset file. So we're really never going to be storing that data multiple times, right? Now, what we would like is to be able to do non-cached reads to the kernel, which is something we could try doing. There are ways that you can sometimes do that, but a lot of times you really just can't. And so there's not much you can do about it other than if you wanted to try to use memory map files. But I don't really like memory map files because they have a bunch of other problems. Not the least of which being that you can't load files that are bigger than 32 bits of address space on 32-bit Windows, which is bad, obviously, right? So yeah. All right. Let's go ahead and close down. Close down. Okay, everyone, thank you so much for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. We finished up that round of asset system work, which is pretty cool. And so now we just have to kind of think about, do we want to write our own memory allocator now that we've got everything arranged and working using the system's memory allocator, right? And so that's what we'll talk about tomorrow, and we'll think about that tomorrow. Until then, if you'd like to follow along at home, you can always pre-order the game on handmadehero.org and get the source code. It comes with the source code. Even today, when we're just working on the renderer, you can already, working on the engine rather, you can already follow along at home if you want and play around with the source code, kind of experiment with it and learn from it. So if you want to do that, handmadehero.org. You can also support our Patreon page if you're so inclined. And you can go to our forums where you can ask questions or get community done episode guide and ports to like Mac and Linux ahead of when we're doing those. And there's also a tweet bot that tweets the schedule at you, which you can go to if you would like to keep abreast of the series' schedule. So if you want to know when we're going to be live, you can check that out. But tomorrow we will be back at 5 p.m. Pacific Daylight Time, so that is when we'll be live tomorrow. No need to check the tweet bot from that. I will see you tomorrow when we will talk about whether we want to go ahead and take that extra step of doing our own memory allocator. And maybe we do, right? Maybe we want to go ahead and spend a couple days on that. That's about it. So I hope you will all have fun programming until tomorrow when I will see you back here. So until then, I'll see you guys on the internet, and take it easy, everyone.